takeoff would have to be one of the most impressive sights in the animal kingdom. And to see something that's 20 feet tall suddenly spring into the air and fly away is outside the bounds of human experience.
For a giant like Quetzalcoatlus, flight control is everything. This flying reptile has one of the most advanced autopilot systems in natural history, akin to a bio-supercomputer.
Imagine just for a moment that you're an animal with the wingspan of a small sailplane, and you are turning yourself 90 degrees. That's not an easy maneuver to pull. Human pilots, for example, rely on instruments in their cockpit in order to do things like that. Quetzalcoatlus has to have those instruments built in.
A Quetzalcoatlus wing is covered with millions of tiny hair-like sensors. These microscopically small biomemory devices collect information, then send signals to the brain.
Their wing wasn't just an aerodynamic organ. It was also a gigantic sensory organ, capturing all kinds of aerodynamically relevant information about things like airspeed, tension in particular parts of the wing.
This data travels from the wing to the brain. Then, in a split second, a Quetzalcoatlus makes minute adjustments to its wing shape and body position. Proof of this advanced biotechnology is found in the flocculus, the area of the brain devoted to flight control. It's 3 times larger than in any bird today.
There's a huge amount of math going on in the brain as it's making these subconscious calculations. And what's key is that's happening all the time. It can never stop because these animals are in the air. And if there's any break in that process, the results are potentially catastrophic.
Nothing this large would achieve powered flight until the 20th century, 65 million years later. And Quetzalcoatlus still may hold the record for flight duration.
Probably stay aloft for a week. Probably could have gone for 26,000 miles in a single trip.
Quetzalcoatlus is one of the most unusual and terrifying carnivores to inhabit the Earth. But unlike predators such as T-Rex and Deinonychus, this flying meat-eater isn't searching for the big kill. It scours the Earth from above, tracking the small, the young, the defenseless, dinosaur hatchlings. Keeping this predator airborne at altitudes as high as 10,000 feet requires a 40-foot wingspan, an accurate guidance system, and near-perfect eyesight.
What we see is an enlarged eyeball, an enlarged eye socket, and the processing centers of the brain, the optic lobes, were also very much expanded.
Its 4-inch retina is packed with over 1 billion light receptors and registers as much as 4 times the detail of the human eye. A Quetzalcoatlus can also see a spectrum of light invisible to humans. Ultraviolet. The urine of their prey absorbs UV rays and then reflects them back. This creates a lighted trail leading straight to their quarry.
These animals had very highly developed gaze stabilization mechanisms, allowing to keep their target fixed and in focus within the crosshairs, if you will, as they were moving through space.
The secret to gaze stabilization is hidden in the inner ear. 3 interconnected tubes form what are called semicircular canals. Fluid fills each canal, and small hairs detect the tiniest movement. As a Quetzalcoatlus's head moves during flight, signals are sent directly to the eye muscles. The eyeballs adjust, keeping an image fixed and perfectly in focus. From 1,000 feet in the air, a Quetzalcoatlus can pick out a T-Rex nest and even count the number of chicks.
I think that a big pterosaur on the ground would have been spooky, because they would be moving around on all fours. They'd probably have those sort of quick, precise movements like birds, but they